Assalamu alaikum. In the previous video, we have discussed the addition of vectors. We know for the addition of vectors, we cannot use ordinary algebra. For the addition of vectors, we use either geometrical method or analytical method. The reason behind is the presence of direction along with the magnitude. So in the similar way, when you talk about the subtraction of vectors, we also use analytical or a geometrical method. In this video, we will discuss about subtraction of vectors using a geometrical method. To subtract two vectors, I take vector A and vector B, which are inclined to each other. Now it appears something like this. I take this one as this line as vector A and this as vector B. Vector B. Then to subtract these two vector quantities, I follow parallelogram law of vectors. So I construct one parallelogram. How does a parallelogram appear? Let me show you. A parallelogram has got the four sides. Which opposite sides are parallel to each other. This is a different color. See, this side, this line is kept parallel to this line. Now I am going to draw another line which will be parallel to this line. Okay. This. Now what I have obtained is nothing but a parallelogram. Okay. Now here these two vectors are represented by the sides of this parallelogram. Then the resultant vector will be obtained or will be shown along the diagonal. Here this is the diagonal. This diagonal gives us the resultant vector. Here in this case, this R vector, which is nothing but A plus A vector plus B vector. This is what? Okay, and it will act along this direction. The direction of this resultant vector must be straight. Now my aim is already in the previous video we have got the final expression which gives the magnitude and direction of the resultant vector. Now here what we did here, R represents the resultant of vector A and vector B. Actually it stands for the magnitude of addition of vector A and vector B, modulus of A vector plus B vector, which is nothing but root of A square plus B square plus 2AB cos theta. So theta is the angle between vector A and vector B. This is what we have learned in the previous video. Now let's subtract vector A and vector B. Now see, when we say the addition of vector A and vector B, we just take the sum of these two vectors. Now to subtract these two vectors, I can follow this method. The vector A minus vector B can be written as vector A plus minus of vector B. Okay, see, vector A minus vector B is written as the sum of vector A and minus B vector. This resultant gives me the subtraction of these two vectors. Okay, so I need to get the value of vector minus B vector from this diagram. So what I do, I just draw a line which represents minus B vector. So to do that, I am drawing a line. Just I extend this in the reverse direction, which acts in the opposite direction and represents a minus B vector. This line which is moving upward gives us B vector. If I reverse it by continuing this line in the opposite direction, I get a minus B vector. Okay. Now if I add A vector with minus B vector, I will get A vector minus B vector. Okay. So let's keep the remaining thing as such. When I have reversed this one, I will follow the same method here as well. Done. Then I'll connect these two ends. I have got another parallelogram. Okay. Now in this parallelogram, this line represents a vector. So the resultant of these two can be obtained by drawing the diagonal. Okay, this is the diagonal. This is the diagonal, and it provides me a resultant vector. It's R vector, which is nothing but A vector minus B vector. Okay. Now I am going to find out the magnitude of R vector. Then we'll get the expression for the direction of R vector. Clear? As we did in the earlier video. I'm going to use these two expressions, these two final expressions to do that. Okay. When we added vectors, we got this expression, root of a square plus b square plus 2ab cos theta. Okay. Here one thing I forgot to mention. I didn't reveal the angle between vector A and vector B. Here, the angle between vector A and vector B is taken as theta. Now, the similar as we did in the previous video. Okay, if it is so, what will be the angle between vector A and minus B vector? It's quite simple. The total angle between vector B and minus B vector is 180 degree. From 180 degree, if we subtract theta, we will get the remaining angle. Let me show this to you. This complete angle is 180 degree. 180 degree. This complete angle. If it is so, you have to get this angle. Which angle? This angle. What do we need to do? We need to subtract a theta, this part, whose value is theta, from 180 degree. Okay. So the angle between A and minus B vector is 180 minus theta. Got it? Now let's go ahead. Fine. It is so. Then A vector minus B vector. So, if you want to find out its magnitude, I'll write here magnitude of the resultant. Let me erase this from the board. That is magnitude of resultant vector. Is that here the resultant is R, which is nothing but modulus of A vector minus B vector. So, from this expression, the root of A square plus B square plus 2AB cos of angle between A and minus B vector. What is the angle between A vector and minus B vector? It is nothing but 180 degree minus theta. This is the angle from the diagram. Okay. Now, just cover this part. Clear? Now, think you know, cos of 180 minus theta is nothing but minus of cos theta. This I am going to use here. Okay, if I do so, I get this modulus of A vector minus B vector equals to root of A square plus B square plus 2AB minus cos of theta. So the next step, plus modulus A vector minus B vector equals to root of A square plus B square minus, here when plus is multiplied with minus, we get minus 2A B cos of theta. Okay, see, let's compare these two equations. This provide addition of vectors. In addition of vector, we have positive sign here, whereas here we have negative sign. Clear? This is the final expression which provides us the resultant of these two vectors. Okay, vector A and minus B vector. I box this for better visibility. Alright. Now let's go ahead. Now I am going to find out the direction of a resultant vector. Direction of resultant vector. What is the direction of resultant vector? I'll want this. I'll use the same method here. Okay. Here, the angle between vector A and this resultant is taken as alpha 1. Similar way, the angle between vector A and this resultant is taken as alpha 2. Okay, actually this is our resultant vector. So tan of alpha 2 will be nothing but this. B, no, right here, in the place of theta, I take 180 degree minus theta. That's all. Sine of 180 minus theta divided by, now here A is kept as such. In the place of cos theta, I take 180 minus theta. That's it. Now, then you see what I do now? I'm going to substitute the value of sine of 180 minus theta. Look at here. Or it might be cos of 180 minus theta is minus cos theta, but sine of 180 minus theta is sine theta. Here we have positive, so it is not mentioned. So yeah, sine of 180 minus theta is written as sine theta divided by, here cos of 180 minus theta is written as minus cos theta. So minus b cos theta. So this is the value of tan of alpha 2. So from this, alpha 2 can be obtained if you take a tan that side. When tan is taken that side, tangent is taken to the side, that side, it gives us tan inverse. Now, I write this part within bracket b sin theta divided by a minus b cos theta. Fine. This is the final expression which provides us the direction of resultant vector. The resultant vector is nothing but a vector minus b vector. Clear? Now I box this. Okay, this is the final expression. That's all. This how one can subtract two vectors using parallelogram law of vectors, and this is nothing but a kind of geometrical method. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.